So we're going to start with filling out the ones that we already know. Now, the reason this is called a unit circle is because your radius is 1 unit. For all of these, R is 1. If you remember the last time, which wasn't last class because I was absent, the time before that, remember we did trig with any angle? Some of you are already zoned out. You can't do that. You got to stick with me, okay? And you remember you did Pythagorean theorem and found blah, blah. You're not going to do Pythagorean theorem because what is R? 1. R is 1 for all of these, okay? Now, this point in the center is the origin 0, 0, which I'm making happy. It's the happy origin, all right? That's 0, 0, where our center is. Now, we have done the compass point ones, the up, down, left, right, or, north, south, east, west. So we're going to go around and do those first. If you're right here, I'll get my paper clip. How far have you rotated? 0. It is 0 degrees. It is 0 pi radians, no pi. And I want you to think about this. If this is the origin and the radius is 1 unit, when you went 1 unit this way, what's the coordinate point? No, this is 0, 0. You went 1 unit to the right, it is 1, 0. Good job. Now we're going to go up. If you rotated up to here, how many degrees did you go? That's 90 degrees. And how many radians is 90 degrees? Pi over 2, it's half a pi. Now, if this is the origin and your radius is 1 unit, you just went up 1, what's your coordinate point? 0, 1. Good job. All right, venturing on around our circle. If you rotate over to here, how many degrees did you go? All right, 180, which in radians is just pi, 1 whole pi. And if this is the origin and you went left 1, what's your coordinate point? Yep. -1, 0. Good job. This doesn't even look green up there. Disappointing. All right. And then if you rotate down to here, how many degrees did you go? Yeah, 270. It's 180 plus 90. Now this is 1/2. This is 2 halves, which is a whole pi. So then this would be 3 halves. You're just counting by halves. 1 halves, 2 halves, 3 halves. And what's the coordinate point? If this is the origin, you went down 1. Yep, 0, -1. And then if you make it the whole way back around, it would be how many degrees? 360, good, and 2 pi. Okay, so those are ones that we've done before. We've done all of those. So let's go back to our piece of paper, like our notes, and we're going to review our special right triangles. We're going to do them one at a time. So we're going to do this one, and then we'll go back to the unit circle, and then I'll do this one, and we'll go back to the unit circle. So if you have a 45, 45, 90, it's going to look like this. And again, for your unit circle, what is your R value? 1. That's why it's called a unit circle. R is 1 unit. I don't really expect anyone to remember this because unless you're a math teacher, you don't walk around knowing this. But I did go over these patterns. The way you get from the hypotenuse to one of the sides, and the sides are going to be the same. Why are they going to be the same? Yeah, these are both 45. Yeah. Does anyone remember what that triangle is called when 2 sides are the same? Oh, good job, isosceles. Nice job. The way you get from the hypotenuse to one of the sides is you divide by square root of 2. Does that ring any bells? Do you remember a square root of 2 at least? Like something like that. Now you have to rationalize. So if you rationalize, what is that going to come out to? Square root of 2 over 2. So both sides are square root of 2 over 2. So if you want to pick a different color, I already used green, so this time I'm going to do pink. We're going to go back to our unit circle and we're going to fill in all the 45-degree ones. So if you rotate, I get my paper clip. If you rotate to here, you have got, this is the one in the middle. Make sure you write it on the correct one. We're going to go do all the 45-degree ones. If you rotate to here, you went 45 degrees. If you want to pick a new color, mine is pink. And in radians, that is 1/4 of a pi. Do you see how this is 1/2 of a pi? 1/2 of a half is 1/4. Is anyone like a baker? You know when you have to like have recipes? There's like, that's kind of what I think of when I do that. Now your coordinate point is square root of 2 over 2, comma, square root of 2 over 2. Both of the sides of the triangle are the same, so they're the same. Now just watch me do this. Just watch. That's 1/4. If you rotate up to here, that's 2/4, which is a half. So if you rotate to here, again, the one in the center, that would be what? Let me try again. 1/4, 2/4, 3/4. There we go. So in radians, this is 3/4. You're just counting. What would it be in degrees? You just need to add another 45. So here's 90. You're just going 40. We're adding 45 each time. 135. Good job. Now again, watch me point to this. We're just going to take this point and reflect it over here. So it is going to be negative square root of 2 over 2, comma, square root of 2 over 2. Do you see how just the x value is negative? You went left and you went up. We're going to try this again. Just watch. 1/4, 2/4, 3/4. Do you see that? 1 whole pi is 4/4. So this next one is 5/4. You are literally just counting. Again, make sure you put it on the one in the middle. This is 5/4. And say that again, what would it be in degrees? 225. You just take 180 and add another 45. Now you're going to take this point and just reflect it down to here. So it's going to be the same thing, except in the third quadrant, they are both negative. Good job. So negative square root of 2 over 2, comma, negative square root of 2 over 2. I'm not going to start at the beginning and go the whole way around again. I'm just going to start here. So watch. 4/4, 5/4, 6/4 is your 3/2. So the next one is good, 7/4. We're getting there. Make sure you put it on the one in the middle. We're doing the center ones. Now you have to take 270 and add another 45. It's 315. Good job. And what do you think the coordinate point would be? Go grab another one. I've got plenty. Hold on a second. So what is this coordinate point going to be then? Square root of 2 over 2, comma, good, negative square root of 2 over 2. In quadrant 4, you go right and then down. So the x is positive, the y is negative. Good, we made it the whole way around. That went well. Barely. Nah, you're fine. So come on back over here. I'm going to attempt to do both of these ones at the same time. We'll see what happens. Now, this is the only time I attempt to draw it to scale. Otherwise, as long as it's in the right quadrant, I don't care. But I'm going to attempt to draw it to scale. Because you have the 30, 60, 90, but it can also be like 60, 30, 90. You can have it both ways. So watch how I draw this. Do you see how I made this angle real small to show you that's the 30? And then that's the 60? I'm over exaggerating it to try and get you to see that that's the small one. Do you see what I'm doing there? Now, what is the hypotenuse? 1. It's the unit circle. Again, I don't really expect anyone to remember this, but I expect when I say it for it to like ring a bell, okay? To get from the hypotenuse to the shorter side, you divide by 2. So if that's 1, this is going to be 1/2. Good. Thank you for coming with me. And to get from that small leg to the bigger leg, you multiply by square root of 3. So this would be 1/2 times square root of 3, which is just square root of 3 over 2. Now, if you take that and make it go the other way, and again, I'm over exaggerating this to try and get you to see it. If I put the 60 here and the 30 here, it's the exact same triangle, just the other way. Your hypotenuse is still 1, it's a unit circle, except what happens to these? Yeah, they flip. This is the 1/2, and this is the square root of 3 over 2. Again, I'm going to attempt to do these both at the same time. If I go too quick and move the paper too fast, just tell me to hold on a second. But I'm going to do both colors at once for this. Because we can handle it. So I'm going to have purple and blue for these. So this first one, we went 30 degrees. So this is purple. We went 30 degrees. I know it doesn't show up. So it's like, it's purple. I can see it on my paper that it's purple, but up there, it all looks black and white. In radians, that is a 6, 1/6, pi over 6. Now watch me point to this. If you imagine the triangle in here, do you have an imagination? Yeah. Can you imagine this triangle? Do you see how in the X direction you went further than the Y direction? Do you see how X is bigger than Y? That means this is your square root of 3/2, and this is your 1/2. This is the bigger one, and that's the smaller one. Okay, I heard an okay there. I'm going to switch colors to blue. You're not going to be able to tell, but I'm going to make this one blue. Your degrees would be what? This is 30, so this one's 60. And we're going to count by 6. This one always makes me sound like I'm lisping, all right? 1/6. This would be 2/6, which is a third. We're going to count by 6 to go the whole way around. You'll see once we get out of quadrant 1. This is 1/6. This is 2/6, which is a third. And all I'm going to do is take these two and flip them. Good. And if you imagine the triangle in here, again, just watch me point to this. Can you imagine a triangle right here? Like, can you imagine this? Do you see how the X is smaller than the Y? Like you went further in the Y direction? That's how I kind of think of that. Okay, let's keep on going. I'm sticking with blue. 1/6. You got to watch. You have to look because I don't have a better way to explain it than, hey, look it. All right. 1/6. This is 2/6. 3/6 is a half. Good. So this next one would be good. 4/6, which is 2/3. So 4/6, 2/3. Now let's do the degrees. This is 60. This is 90. Add another 30. 120. Good job. You guys are coming with me on this. Now look it. All I'm going to do is take this point and reflect it over here. Do you see how these two connect? Take this point and reflect it over here. It will be -1/2 square root of 3/2. Do you see how those two connect? And do you see how I made both of these blue? I mean, you're like, no, we don't see it, Miss Cole, because the color is not there, but these are both blue. Do you see that? Okay. Now I'm going to switch back to my purple because I want these two to both be purple. Do you see how they reflect? This is purple. So I switch back to purple. I'm going to count again. Just watch. 1/6, 2/6, 3/6 is straight up 4/6. So this next one is 5/6, which should make sense because what's 1 whole pi? So good. See, you're coming with me on that. All right. So 5/6. This is right. What do you think in degrees? Good. How did he get 150? Somebody else. Add the perfect. Like, this is going so well. All right. And now watch. You're going to take this point. This is why I made them both purple. See how they go across? You're going to take this point right here and reflect it over. So it is negative square root of 3/2, comma a half. I'm going to stick with purple because I want these two to reflect. Do you see this next one we're getting to? Okay. This is 6/6. So what's the next one? 7/6. Good job. My purple is running out here. I'm making it the same as this one. So I'm on purple, but whatever color you made the 5/6, do you see how these are reflecting? Yes. I'm trying to make the ones that reflect the same color so that you can see them. Like, I'll show you this one when I'm done so you can actually see it. All right, and what do you think in degrees? 210, good. Now I'm going to take this point where the 5/6 is and reflect it down here. So it's going to be what? Negative square root of 3/2 and then -1/2. Good job. I'm gonna have to pick a different color than purple for my next class because that is practically done. All right, this is 6/6. This is 7/6. So this one is good. 8/6 reduces to 4/3. So I'm making this blue. I want it to connect with this one. Again, I can't show you the whole circle because if I zoom out, you won't be able to read anything. But I'm making the ones that reflect across from each other the same color. So what do you think about degrees? Just add another 30. Yes. 4/3. 8/6. Yeah, and some people will like write that off to the side. You can do that. All right. And then you want this point right here where the 2/3 is to reflect down. So it's going to be -1/2, negative square root of 3 over 2. Does it feel like, get your head up. That's a respect thing. Does it feel like we're writing the same thing over and over and over again? Good, that's because we are. I'm sticking with blue. 6, 6. This is 7, 6. This was 8, 6. 9, 6 is the 3/2. So this next one is 10, 6, which if you want to write that off to the side, that's fine. That would reduce to 5/3. Good job. In degrees, add another 30. 300. Sounds like you're setting your oven to preheat or something. All right, and you're going to take this point right here that I'm pointing at and reflect it over. So these two reflect. So it's going to be 1/2. Good. Negative square root of 3 over 2. All right, one more. I'm going back to purple. Hopefully this marker will fold out until I finish this last one. So that was 10, 6. So the next one is, which should make sense because what's the whole way around? 12, 6, which is perfect. All right, add another 30. So 330, which should make sense because if you add 30 again, you get 360. Yay. And then you're going to take this point. Look where the 7/6 is. See how this connects over? So this is the point we're reflecting over, and it is going to be square root of 3 over 2, comma, -1/2. Congratulations, you filled out your first unit circle. There are many more to come. You're going to fill it out a lot of times. You're going to do okay. Oh, let's have that pep talk real quick. Do we memorize this? No. We know it. There is a difference between memorizing and knowing something. Did I just start at the beginning and just go around and spit a bunch of numbers at you? No, I counted it out and I explained where they came from. That's how I want you to think through it. The people that try to memorize it get things backwards, and they only know it for 5 seconds and then they immediately forget it. We don't memorize this. Good job. Perfect. All right. I'm going to say one more thing and then I'll give you a break because that went really well. What you need to remember is small, medium, large. Your small angle is the 30 degrees or pi over 6. If I give you a 1/6 of a pi, that's a little slice. Do you get what I'm saying? A 1/6 is a small amount. All right.
The ones are the ones that are halfway.
Correct. Yes. Yes. But I don't think of it that way. I do 45s and then I do the 30s separately. Okay, however your brain does it. All right, the medium angle is 45, which is pi over 4. That's the one in the center. And then the large angle is 60, which is a third. A third of a pie is a lot of pie. I do not recommend eating a third of pie. That will give you a tummy ache. All right. Yeah. Now, remember from last unit with our law of sines and cosines, the small angle goes across from the small side. The medium angle goes across from medium side, and the large one goes across from large side. So this goes across from the 1/2. This goes across from the square root of 2 over 2. And this goes across from the square root of 3 over 2. Do you see how it goes 1, 2, 3? 1, 2, 3. Small, medium, large. Now we're going to go back to our trig functions. I'm going to just draw this in quadrant 1 for the sake of putting a triangle somewhere. Obviously, if you're in a different quadrant, you have to watch your negative signs. This is X, this is Y. What is R? 1. So we started out with sine being opposite over hypotenuse. Remember that, SOHCAHTOA? Then we went to it being Y over R. But now it's Y over 1, which is just Y. Because R is 1. That's why that happened. And then what is cosecant? Well, you take Y and you flip it. I'm going to say something about that, though. I do not want you to think of it as 1 over Y. That messes everybody up. Just think of it as reciprocal. Just flip it. If you start trying to put 1 over square root of 3 over 2, you are going to get so confused. Don't put 1 over, just flip it. Okay? You'll see when I get to a problem. Cosine. We started out with that being adjacent over hypotenuse. Then we realized it was x over r. Now it's x over 1, which just is x. And so for secant, you're going to flip x. Again, just flip it. Don't put 1 over square root of 2 over 2. That's horrible. Just flip it. Okay? Tangent is opposite over adjacent, which is going to be y over x. And so cotangent, x over y. That didn't change because that doesn't involve the hypotenuse. Okay? So here are your steps for this. There's 4 steps for figuring these out. I didn't used to teach it with steps, but then people were like, Miss Cole, I would like some steps. So if you're a steps person, like do this, do this, do this, here's your answer. I've got you. Step 1, you're going to figure out what quadrant you're in. Kiddos, there's only 4. If you get stuck, pick one. Okay? There's only 4 quadrants. Then you're going to figure out what your reference angle is. If you're in degrees, your reference angle is 30, 45, or 60. Those are the only options. If you're in radians, it's pi over 6, pi over 4, or pi over 3. These are the only choices. There's only 3 choices. Pick one. Your world is very tiny. This is it. Okay? Then you're going to put the sides of the triangle, which your only options for those are 1/2, square root of 2 over 2, and square root of 3 over 2. These are the only options. If you are stuck, pick one. Just give it a guess. You only have 3 choices. All right? And then you give the answer, which is based on what we just said right here. Do you want y? Do you want x? Do you want to flip one of them? You know, what does the problem say? Okay, so those are your steps. If it's in degrees, I want you to think in degrees. If it's in radians, I want you to think in radians. Do not switch back and forth. Also, and you're like, why is she harping on? It's because I've done this a long time and I know where the mistakes happen. On a test, I want to see the amount of work I'm writing here. And it's a triangle, so work with me. I'm not asking for that much, but I will not accept just an answer. I want to see a triangle, okay? 210, what quadrant is that in? You only got 4 to choose from. 3, good. Draw a triangle in quadrant 3. We did step 1. Go us. Next is your reference angle. It is either 30, 45, or 60. Now, if you're at 210, what do you think? 30. Good job. How'd you get 30? That's 100% correct. Yeah, 210 minus 180. 180 plus 30 is 210, however you want to think of it. 30 is the little one. Across from the little one is the little side, which is 1/2. So across from the 30, I'm going to put a 1/2. That means the other side is square root of 3 over 2. That's how they go together. Now, we're not in quadrant 1, so one or the other or both of them has to be negative. What do you think? Why are they both negative? Left and down. That is the amount of work I want to see. That is not that much. That is your work. Okay? Now you answer the question. It says sine. Sine is y. Which one of these numbers is y? -1/2 is your answer. This is the work. That's the answer. Once you get good at these, you can churn them out. I might not do all of them because I want you to have time to practice on your own, but let's just do like a handful more of these. Careful because you're going backwards in this one. If you go backwards 300 degrees, what quadrant are you? 1, good job. You went backwards almost the whole way. Now, if that was 300, what's your reference angle? 60, good job. 60 is the big one. Remember how there's small, medium, large? 60 is the large one. Or what is that? I just had a thought, like what is it in Starbucks terms, like tall, grande, venti? That's the venti one, all right? Yeah, I know, right? Across from the biggest one is the biggest side, which is square root of 3 over 2. So across from that, you have square root of 3 over 2. That means the other side has to be 1/2. Is anything negative? Why not? Quadrant 1. Good. This is your work. That is the work I need to see. Now you answer the question. It says cosine. Cosine is x. Which one of these is the x number? 1/2 is your answer. You're all waiting for it to get harder. I can't make it any different. That's it. Okay. Let's maybe do just like 3 or 4 more. All right. What quadrant is 5/6 in? 2. Good. Perfect. Now here's where you're going to love radians more. The denominator just matches. So what's your reference angle? No. Pi/6. And I'll mark that wrong. I know I'm not trying to be hateful, but you got to let the degrees go. 1/6 is the tiny slice. If I give you a 1/6 of pi, that's not very much. That's the small one. Across from the small one is the small side, which is 1/2. That means the other side, what's negative? Something has to be negative. Good. Your x value. You went left and then up. That is your work. Now you answer it. Tangent is y over x. So let me show you how this looks. It's going to be 1/2 over negative square root of 3 over 2, which I get you're like, okay, that looks horrible. But do you see how these 2's are going to cancel? So it's negative 1 over square root of 3, and then you rationalize negative square root of 3 over 3. Let me find one that's going to be the square root of 2's. Did I not? Oh, the next one will be. What quadrant is negative pi over 4 in? You went backwards pi over 4. 4, good. And your reference angle is pi over 4. By definition, reference angles are positive, so just don't ever put a negative in there. Now for the pi over 4, that means both sides are the same, square root of 2 over 2. Now, which one's negative, the x or the y? Good, perfect. That is your work. Now we answer the question. Cosecant means you flip the y value. So we're going to flip this one. So it's negative 2 over square root of 2, and this is going to look awful for a second, and then a bunch of stuff's going to cancel. When you rationalize that, you get negative 2 square root of 2 over 2. So just negative square root of 2. Now, you can do whatever you like, but I usually try to tell people, if you flip square root of 2 over 2, you just get square root of 2 because everything cancels out. So let me maybe pick like 2 more. Did we do something in quadrant 3? Have we done every quadrant? We did every quadrant. Okay, then let me maybe do, I'm going to do like 2 more. Let's do this one. Let's do 9. Oh yeah, go ahead. Oh, no, if you don't put that, that's fine. I do want to see this though.
Yeah.
Okay. The reason I don't need the 90 degrees, they're all 90 degree. Same thing with like R is 1. I get people that like to put the 1 there on every single one. I don't need that. They're all 1. Okay. Let's do 9 and 10. 3 pi over 2. Look at your unit circle that we just filled out. That's not going to land in a quadrant. So you're not going to get a like triangle. Is 3 pi over 2 up, down, left, or right? 3 pi over 2. Look at your unit circle. Down. So instead of a triangle, you get a circle because it lands on the axis. So what is that coordinate point? Good. So if it lands on the axes, that's the work. That's the amount of work I need to see. Again, I'm not asking you for a whole lot. No, because it landed on the axis, so there's no way I can make a triangle out of that.
Oh.
It won't. Oh, good. I like hearing that. It won't form a triangle because it's on the axis.
So
If it's one of the compass point ones, you get a circle instead of a triangle.
okay.
Well, if you want to argue the point, listen. Technically, you have a circle every single time. Do you see what I'm saying? It's a triangle within a circle, but I'm not going to make you draw a circle every single time. That's so technically you have a circle all the time.
The circle reappears because you can't make a
You can't make a triangle. All right, hold on. I want to be able to do 2 more. Sine is the y value. Which one of these is the y value? Yeah, -1 is your answer. I'm going to do 1 more.
Oh, wait, that was easy.
Yeah. Let's do tangent of pi. Where's pi? Up, down, left, or right? Left. So what's that coordinate point? -1, 0. That's your work. That is your quote unquote work that I need to see. Tangent is y over x. So that is going to be 0 over -1. Now here's where everybody loses their mind. It's either 0 or undefined. If the numerator is 0, it is just 0. If the denominator is 0, that's when you get an undefined because you can't divide by 0. Okay.
0.
And when the denominator is 0, that's where you get an undefined.